Good morning, everyone. I'm going to go ahead and make a key for the stoichiometry problem, target 8.1, our first problem. So I really want to give you a video here where we can walk through the entire thing, where I can point out all the things that I'm looking for. So this will probably be a bit, I'll go through this problem a bit more slowly than I would expect you to. But yeah, follow along. Let's see what's going on. So what we have here is a nail placed into a copper salt solution, copper sulfate specifically, I believe. And you can actually try this out sometime if you want. If you get any sort of coppery salt, there are ways to get them. I think a lot of like root killers and stuff have this stuff in it. Actually, I think you can literally buy this exact stuff at the hardware store called Root. It's just called Root Killer there. Drop some nails into it, and the copper will come out. It's kind of cool. But anyhow, this is a reaction we would have done in class, and we just, sorry we don't get to do it. So let's go ahead and look at our task here. Copper 2 sulfate, an iron nail is placed in a solution of copper 2 sulfate where it reacts. Solid copper, which you can see in the image below, that's the orange stuff on the outside, begins to form on the nail. At the same time, iron from the nail combines with the sulfate to make iron 2 sulfate. I forgot to mention that it goes into solution, that's fine. Our nail started off with a mass of 1.25 grams, but after the reaction is a mass of 1.03 grams. It's actually really cool when we really do this. The nail physically gets thinner. So what I usually do is I hand a student a nail that went through the reaction, and then I hand a student a nail that didn't. And you can't really see it with your eyes super well, but your fingers can 100% tell that one of the nails has gotten thinner. And it's literally from the iron atoms being ripped off during this reaction. It's pretty cool. So, questions we have is what mass of iron was lost? How many moles of iron is that? I need a balanced equation for the reaction, the BCA table that goes along with it, and finally, what mass of copper would you expect to have formed on the nail? So we're going to go through this step by step. I'll show you my math. I'll let you know everything. So, what mass of iron was lost? Well, the iron started off at 1.25. Let's see here. The iron started off at 1.25 grams, but then afterwards it's only 1.03 grams. So we've lost some. Some of that iron went somewhere else. How much? 0.22 grams. So we have 0.22 grams of iron that has undergone a reaction. Question number 2, how many moles of iron is that? Well, 0.22 grams of iron, where I know that, oh, let me look it up. Here, I'm looking it up, you can't see it. The molar mass of iron is 55.85. So 0.22 grams of iron, where we know that 1 mole of the iron is 55.85 grams. As a reminder, always make sure that your molar mass is set up so that you can cancel out the grams. When I run this through my calculator that you guys can't see, I end up getting 0.0039. I'm tempted to raise that up to 0.4, but I think 0.39 will work for now. Grams, we're left with moles. So this is the number of moles of iron that we have. I do hope that you remember how to do those mole to mass conversions because they're absolutely necessary for what we are doing in this unit, in this target. All right, we need a balanced equation for the reaction. This equation isn't too bad. We know that we have pure solid iron. We are reacting that with copper 2 sulfate. Now, copper 2 sulfate is Cu2 plus and SO4 2 minus. Because this one's 2 plus and this one's 2 minus, we can just combine them 1 to 1. Remember, same number of pluses and minuses means we're good. So I'm just going to go ahead and put together 1 copper with 1 sulfate, and this was dissolved in water. These two are going to react, and we are told that they end up making solid copper and iron 2 sulfate. So same deal. Iron 2 is iron with a 2 plus charge, and then sulfate is SO4 2 minus. two pluses, two minuses, they can just go together 1 to 1. So FeSO4. I don't tell you in the problem. I would probably accept whatever you put, but I will say in real life it does stay dissolved, so it stays aqueous. This is done. Actually, this is even balanced. If you look here, one iron, one copper, one sulfur, four oxygens. Yeah, we're set. We are balanced. That part is done. So, good job, number 3. So we've gone through question 1, question 2, question 3. Let's do the BCA table. So remember, BCA tables are where we're just keeping track of the moles of everything. So I'm just going to go ahead, finish making this real fast. And what we're going to do is we're just going to start filling in the things that we know are true. So B stands for before the reaction. Well, one thing I know is before the reaction, oh gosh. Actually, I don't know exactly how much iron I had. We didn't do the whole nail. Tell you what, if you put the whole nail in here, you will get, I think you get like 96 moles. Sorry, no, correction, you don't get 96 moles. You get, oh gosh, who knows? You get some amount. But thing is we don't actually know how many moles of iron there were in that nail. At least I haven't calculated it. What I have done, though, is I know that we use 0.0039 moles. So the amount that we use goes under C. That's the change. We know that that nail dropped by 0.0039 moles. Second, we know that we didn't have any copper when we started. Not pure copper. We had this copper, but that copper was floating around in solution. This is solid copper. We didn't have any of that yet. We also know that this iron sulfate, we didn't have any of that to start either. The iron here, we had an entire nail, and I don't know how big that is, but I know that it was enough to do this reaction. So we have a symbol for that. Excess. By the way, you actually could figure out the value that goes here. You're welcome to. If you did it, it will not be marked wrong. I just personally am fine with calling that excess because I know that we had more than enough nail. And when we end, we still have nail left over. So again, we have more than enough nail. So the copper sulfate's the tricky one. Because I don't actually know how much copper sulfate we had. Remember, the copper sulfate's the blue stuff in the solution. When the reaction is done, it's all gone. The solution isn't blue anymore. So I'm pretty sure we end up where we've used up all of the copper sulfate. So let's think about this. One iron reacts with one copper sulfate to make one copper and one iron sulfate. All right, that's what these mean. One iron, one copper sulfate, one copper, one iron sulfate. Well, if we had 2 irons, then I would need 2 copper sulfates. If I had 10 irons, I'd need 10 copper sulfates. If I had 1,000,000 irons, I'd need 1,000,000 copper sulfates. If I had 0.0039 moles of iron, well, I need 0.0039 moles of copper sulfate. Because in the equation, we need the same number of each of those, that must hold true even when we scale it up. Remember, this 0.0039 moles is a huge number. It's in the billions of trillions. But even though it's a big number, it's just this same recipe, just done a few billion trillion times. When we do this recipe, we always use the same exact number of irons and the same exact number of copper sulfates. That doesn't matter if we do it once, twice, 10 times, or 0.0039 moles times. Similarly, we're going to make copper. One of these makes one of these. So 0.0039 moles of these must make 0.0039 moles of these. Look, same thing. One iron should be able to make one iron sulfate. So 0.0039 mole iron should make 0.0039 moles iron sulfate. So we started off with no copper. We made 0.0039 moles. So what do we end up with? 0.0039 moles. We started off with no iron sulfate. We made 0.0039 moles. What do we end up with? 0.0039 moles. Finally, we don't know how much copper sulfate we started with, but we know when we used up the 0.0039 moles of copper sulfate, we ended up with none. So I think we must have started with 0.0039 moles. All right, when you're working through this problem, places where I will give you some leeway. So by the way, this is the BCA table as I personally would make it. But if you're working through this problem yourself, there are a few places where I'll give you some leeway. If you actually know the number of total moles in that nail and the total moles that are left over afterwards, you're welcome to do that. Just take the 1.25 and 1.03. That's the number that goes right there once you turn it to moles, and that's the number that goes right there once you turn it to moles. I don't need that, but it would not be wrong to do. Second, I could, because I didn't give you the information that all the copper sulfate is used, and because you haven't done the reaction yourself to actually see the color change, I will be pretty forgiving on this end of things. This is something that we lose out on because we can't really do the lab together. You don't get to really see the evidence, oh, this copper sulfate must be gone. Because of that, I will be pretty forgiving there. But this change row is not forgiving. This change row needs to follow the ratio in the balanced equation. If these four numbers are the same, then these four numbers must be the same. These ones are negative because we're destroying these, and these ones are positive because we're making these, but the actual number themselves needs to be the exact same. I'm not going to be too forgiving on this stuff. This stuff should match. I don't see any real reason why it shouldn't. Maybe on a case-by-case basis I could see some reasons, but I personally don't anticipate any now. This is the BCA table that I want to see. So, number 4. All right, last one, number 5. What mass of copper would you have expected to form the nail? So what we need to do is we need to look for the copper formed. How much copper did we make? So let's look back here at our BCA table. The one here that's the copper is this one. So we're looking for something in this column. Now, how much copper was made? Well, we started off with 0, and then we made 0.0039 moles. So what I'm going to do is I'm going to use that 0.0039 moles to figure out how much copper we made. We know that we have 0.0039 moles of copper that we just made. And we want to see what mass that would be. All right, well, I'm going to go look at the molar mass of copper. I end up getting 63.55. And once again, we need to arrange our molar mass to cancel out moles. So this time, or cancel out what we don't want. This time I don't want moles, so I put moles on bottom, and I put the 63.55 grams on top. I'm going to go ahead, run that through my calculator. I get 0.25 grams of copper. Let's change that color to be consistent. 1 second. But yeah, if we do this reaction, we end up losing 0.22 grams of nail and gaining 0.25 grams of copper. We're not creating any mass. What we're doing is exchanging it. This iron breaks, 0.22 grams of this iron gets dissolved into the liquid, and 0.25 grams of this blue stuff actually solidifies onto the nail. So we see this exchange. Afterwards, our nail, we can remove that copper from it. All right, everyone. So this is our first chance of the BCA table. I'm hoping that you follow what it means. I'm hoping that you follow how to put it together. Please do let me know. Stop by office hours if you have any questions. but this is what I expect you to be able to do. I'll post this video along with an annotated key, so hopefully between those two, if you can't make office hours, they'll help out. Also, feel free to let me know if there's another time that'll work for you. Maybe, maybe you need to work in the evening. That's fine. Just let me know. We can work something out. All right, everyone. Talk to you later. Have a nice day.